This is the solution for Lab 3, Part 1, where you will add extra functionality to your Node-RED application by finding and using nodes that Node-RED contributors have created. By the end of Part 1, you will have created your own interpreter. This is available on GitHub as a starter kit and will look something like this. In the second part of the lab, you will be working with the OK Watson starter kit. Both of the links are provided in the steps. This lab assumes that you have completed Labs 1 and 2 and have a running Node-RED instance on IBM Cloud. When you start with Node-RED, your instance comes with a standard set of nodes, such as HTTP-in, functions, and templates. But there are hundreds of community nodes which you can import. Go to flows.nodered.org, which is where the Node-RED libraries are. You can search by all, just flows, or just nodes. Search for microphone under nodes. You should see 2 results, and in the results you can see the versions and the number of downloads. Click on the Node-RED Contrib browser utils and you will see that it also includes nodes for camera, file inject, and unzip. Go back to the library and search for audio. You will be installing the Node-RED Contrib Play Audio node as well as the browser utils. Go to your Node-RED app and create a new flow called Interpreter. To install the browser utils, go to Options and then Manage Palette. You are presented with the nodes which are already installed. Click on the Install tab and then search for Browser Utils. Click the Install button and install again. You will get a message to say that it is successfully installed once completed. Next, search for Play Audio and then install the node. Close the window once you have finished. Before you build the interpreter, create a quick flow to test the microphone and the quality of the audio that it is producing. Add the newly installed microphone node to the canvas. The microphone node uses browser capabilities that are only available on Chrome or new versions of Firefox. Switch to either of these browsers if you aren't already. The microphone needs access to your computer's microphone, which is only possible on HTTPS, so make sure you are using that at this point. Add a delay node and a play audio node onto the canvas and wire the nodes together. Deploy your app and inject the microphone node. The browser might ask for permission to use the microphone, so click Allow. Speak into the microphone and after a delay of about 5 seconds you should hear your recording back. Now you are ready to create the interpreter. First of all, you need to add some more services into IBM Cloud. Go back to your dashboard and search for speech to text. Add the service, checking that the region, organisation and space are the same as the previous services that you added. Go back to the catalogue and repeat the steps for text to speech. And finally, repeat the process for Tone Analyzer. Tone Analyzer will be used in Part 2 of this lab. These new services need binding to your Node-RED app, so head back to your dashboard and connect each new service. Click on the Node-RED app and then go to Connections. Click Create Connection and choose the 3 new services one at a time. Remember, only restage once you've connected the 3rd service to save waiting. Wait for the app to finish restaging and then head back to Node-RED. You will need to refresh the page and log in again if you've created credentials. I need to merge the changes as I was in a different window. On the interpreter flow, add a speech-to-text node onto the canvas and then delete the wires on the existing nodes. Single-click on the speech-to-text node and click on the Info tab. You will see that the input is expected to be passed in on message.payload, but the audio transcription should be returned on message.transcription. Double-click on the speech-to-text node and set the language to US English. Deselect the speaker labels as you don't need that for one person speaking. When you're finished, click Done. Delete the delay node as there's no need for this anymore. Add onto the flow a language translator node, and then single click on the node and go to the Info tab. You will see that it is expecting the input on message.payload. The issue here is that the speech-to-text node sends outputs on message.transcription, but the language translator wants the input on message.payload, so the two nodes cannot be connected directly together. To get around this, add a function node onto the canvas. Call the node Prepare for Translation and paste in the code from the steps. This code sets message transcription as the payload so that the translator service will be happy. Click Done when you're finished. Connect the new nodes together and then double-click on the translator node. Select a source language, so the language that you've specified in the speech-to-text node. I'm using US English. And then choose the target language, which is what you want the service to translate into, and click Done. Next, add a text-to-speech node onto the canvas and put it after the translator node. Note from the Info tab that input should be passed in on message.payload and output will be passed in on message.speech, so the text-to-speech node cannot be connected directly to the play audio node. Double-click on the text-to-speech node and specify a language, voice, and format. The language should be the same as the target language in the translator node that you set, so Spanish in my case. To link the text-to-speech node to the audio node, add another function node to the canvas. In it, add message.payload equals message.speech and name it Prepare for Speaker. Finally, wire the nodes together like so. You are now ready to deploy your interpreter, so press Deploy, inject the microphone node and speak into your computer, waiting for the translated output. This is the end of the first part of Lab 3, where you have added new capabilities into your Node-RED instance, built an interpreter that converts your speech to text, translates the text, and speaks back a translation of your speech.